Okay, so thank you all very much for coming. It's definitely great to see so many people here and there who are interested in learning about Ethereum, learning about blockchain technologies. How many people here have heard of Ethereum before? How many people here are already working on projects, either on Ethereum or on any blockchain platform?
Relatively small.
No, that's okay. Everyone has their first project. So I guess I wanted to and start off by I'll give a very brief introduction to the platform, and then I'll just take questions. So for those who are not too familiar with what blockchain technology is, the way that I usually describe blockchains is I call them decentralized networks with memory. Right? So there's two parts to that definition. The first part of that definition is decentralization, and the second part is the memory. So decentralization is something that should be fairly simple to understand. It's this idea that you can have a network of computers which is not controlled by any single computer, which is not controlled by any single person, company, organization, or a government. So you have a network that's spread out all across the world, and there is no single person or any single thing in charge. Now, decentralized networks are something that we've had for over 10 years now. So how many people here have used BitTorrent before? Okay, some. So let's even the internet itself is, you could say, at least partially a decentralized network. So why is decentralization useful? So first of all, because decentralization is useful when you want to create a system that anyone can trust. So if I create a system and I'm the person running the system, then people who trust me will trust the system. But people who don't trust me are not going to trust the system. And so if you want to have a system that gets used by and easily adopted by a very, very large number of people, then the easiest way to make the system clearly trustworthy is to build a system that does not depend on any one particular person operating it. So that's decentralization. But there's another important part to the definition of a blockchain, which is memory. So if you think about BitTorrent as one example of a decentralized network, it's a decentralized network for sharing files. So I have a file, and I could send this file to one other person. After I send this file, I still have the file. I could send this to some other person, and then I could send it to a third person. Now, so people, maybe about 10 years ago, even long before Bitcoin started, were thinking, well, we have decentralized networks for sending messages. We have decentralized networks for sharing files. Can we have decentralized networks for money? Can we have some kind of peer-to-peer digital currency? And the problem with digital currency that makes it so different from other applications is this. Let's say I have 100 digital rubles. And I send those digital rubles to one person. Now, let's say I then make another transaction. So I send out a second transaction, and this second transaction sends the exact same 100 digital rubles to another person. Now, clearly, both of those transactions cannot pass through at the same time, right? If they can, then that means I converted 100 digital rubles into 200 digital rubles, and the digital ruble will hyperinflate faster than Zimbabwe. So the problem is that the system has to somehow decide, first of all, that when I send the first transaction, that I do not have the money anymore. So before, I have 100 digital rubles. Then I send the transaction. After, I do not have the 100 digital rubles anymore. So the system has to have some kind of memory in order to be a system that you can use to build money as an application. And this is the problem that blockchains solve. So blockchains are a technology for implementing some kind of common shared database, common shared registry, some kind of network between computers, between organizations, between people, which has some kind of memory. So Bitcoin peer-to-peer digital currency was the first application. But after this, people started to think, what other kinds of applications can you do with this? And people started thinking, can you use blockchains to implement decentralized registries for other kinds of digital assets? Can you use it to implement decentralized systems for financial contracts, for other kinds of agreements, for just storing the information about products getting manufactured and passed through the supply chain, about people's identities? And so the number of applications that people wanted to do on a blockchain continued to increase. Now, the idea behind Ethereum is this. Because there are so many different applications, it does not make sense to make a separate blockchain for each one of them. It also doesn't make sense to make one blockchain that has a specialized feature for each type of application, like a different type of transaction for every different thing you want to do. So the number of applications is just too large. So what do we do instead? Well, we can have a platform that has a built-in general-purpose programming language, and inside of the rules of this general-purpose programming language, we can just let people write programs where these programs express the rules of how the application works, what the application can do, under what rules it accepts transactions. So we can have a blockchain which understands this kind of programming language, and if someone wants to build an application, they would write the rules of that application as a computer program, upload it, and anyone can interact with it. And in this way, you can have one blockchain on top of which people can build any kind of application in any industry that they want to. So that's a simple introduction into the idea of what Ethereum is. So I guess from here, I'll take questions.
Yeah, I think I will start from one short question which requires a bit introduction. So technically, Ethereum does the same like bank does. They sell trust. The question is that right now we think that what is written in the code, which is observable from anyone, it's truth. So the question, the human nature have the mistakes inside. And written algorithms sometimes can give you mistakes. And it does not mean that it could be a conditional mistake. For example, sometimes we think that this algorithm is correct. Sometimes after some short period of time, we can think that not. Or we can have idea that we think that it should be true, but someone find a hole inside. And recently, in this Ethereum world, you have a problem with this stock exchange. If you are not aware, just short message that due to the bug into the code which is written for the support of stock exchange, it was some significant amount of monies was taken out away from this place. So this technically it's truth, and this correct way to steal the money. So the question is that we have a human-based mistake and necessity for human correction in this unrecoverable and immutable database and immutable set of worldwide virtual machines. So what we have to do in such a case?
So I think this is definitely one of the kind of very significant challenges. And unfortunately, blockchains are the kind of environment where if some mistake happens, then reverting the mistake is very, very difficult. And so the main kind of solution that we would have to do is basically find ways to reduce the risk that mistakes will happen in the first place. So basically increase the security of the platform, and come up with ways that make it easier for people to build applications that are secure, to build applications where the rules of the smart contract say actually do what the person thinks they are going to do, where users can't as easily lose control of their coins and their accounts, and so that the number of situations that we actually can't recover from is very small. Now, this is not the sort of thing that I think has any kind of magic bullet. I think this is the sort of, solving this problem is going to require a combination of many different approaches that we've already started working on, and probably more approaches that we'll learn over the next several years as we get more and more experience. So, I mean, part of this will involve things like good programming practices. Part of this will involve like more secure wallets. Part of this will involve like things like automated formal verification of code and like a few other things.
Okay, so we see that it should be moved again to the idea that some other people have to implement the better practices, and when we see these mistakes, then we have to make any efforts to not to have it in the future by organizational measures. Okay, this is one of the answers, as I correctly understand.
Yeah.
Okay, so any questions from the public? Okay, let's.
Hello. What is the blockchain size of Ethereum today? And do you plan any procedures to reduce the growth of blockchain size? Thank you.
So the size of the blockchain itself is about 10 gigabytes. The amount of space that an Ethereum node will take up on your hard drive depends heavily on what specific Ethereum implementation you use and in what configuration. So like, for example, if you have a Go Ethereum node, then it might take anywhere from like 20 to 100 gigabytes, depending on like how long it was since you started the node. If you use parity, then it might be 10 gigabytes, and if you use parity in another setting, then it might be only something like 2 or 4 gigabytes. So in the future, there are optimizations that are happening. I know with both Geth and parity to try to reduce the amount of space needed on your hard drive. But in the long term, we are this is part of the blockchain scalability problem. And this, and the blockchain scalability problem is a result of the fact that in all current blockchains, every single node in the network has to process every single transaction. And so if we can find some way of making blockchains that don't have that property, then we can increase scalability of like processing capacity and storage efficiency by quite a lot.
So the distributed algorithm is a key for the solution of this problem. Okay, please.
Hello, my name is Denis, and I have next question. You said that cryptocurrency, it's other world of money. And when we will have opportunity to buy something in usual shop, using, for example, some analog of bank card for everyday, каждодневной основе, everyday based. How do you think?
So when will cryptocurrencies be as useful in like regular everyday transactions? I think it is going to take more time, and I think like cryptocurrencies do have several problems right now. So one of them, for example, is just that there's not much infrastructure that people can use to easily accept it and to easily spend it. Another is that at least like in Bitcoin transactions, these are very high right now. And like Bitcoin is probably the platform that does have the most advanced, at least like point of sale merchant infrastructure. And like Ethereum, the fees are much lower, but much fewer people are using it as a currency right now. Then there's aside from this, there's also a price volatility, and I think price volatility is one of the kind of very significant issue. Is that if not many regular people are going to be willing to accept payments in a currency whose value goes up or down by 20% every day. So that's something that is going to either the volatility of existing cryptocurrencies will need to go down by a lot, and I'm not sure. I don't think that's likely to happen anytime soon. Or we'll need to find ways to come up with new cryptocurrencies that have a more stable price. Relative to things that we actually buy. So with And also, and I think as far as like cryptocurrencies becoming every day, I think it'll happen kind of, I mean, there are going to be some sectors where they will be used more and more, and there are going to be some sectors where people will just continue sticking with existing forms of payment. So for example, any kind of international payments. So for example, the Ethereum Foundation already uses cryptocurrency to just pay international contractors in like the 10 countries where we have developers, and this is much more convenient than banking. So that's something that we're already doing. But as far as like any particular other area goes, like there's the areas where there's more and obvious clear advantages to using cryptocurrency are the ones that are going to accept it first. And just like regular consumer payments might probably be one of the ones that comes later.
Okay, so I just want to emphasize for the people who are not that familiar with that blockchain itself is a foundation for different purposes. And one of the built on top of blockchain is blockchain coins, bitcoins, and some other things. It is not equal to each other. Also, the Ethereum is a different approach that is not the kind of I don't know, Bitcoin, but it's have its own currency and own approach like a virtual code running on top of blockchain basics. So remember that it's a different things. Okay, so please.
Hello, my name is Kenneth. So my question is generally about cryptocurrencies, like decentralized cryptocurrencies. So now with the normal currencies, when we have economic problems like inflation or stuff like that, the government either pumps more cash into the system or reduces the amount of cash in flow to curb the economic problems. Mm-hmm. But if we have something like cryptocurrencies like Bitcoin or Ethereum, the government can't do this directly because it's not controlled by any single person. Mm-hmm. So what do you think should be done in this case? And again, my second question is also connected to the first one. So do you think we should have cryptocurrencies alongside the normal currencies, or they should completely replace the normal currencies? Thank you.
So this is one of the reasons why I think cryptocurrencies are going to be more volatile than fiat currencies for a long time and possibly forever. And I mean, I think that realistically, we are not going to see cryptocurrencies completely displace fiat currencies anywhere. And I think realistically, they are going to continue to exist side by side, and there will be some areas where cryptocurrencies become more popular and some areas where they won't. I mean, like at this point, like if cryptocurrency was just all we had with current levels of technology, I don't think it would be able to run a global economy well. I mean, like in the future, technology can improve, and we'll see. Yeah.
Again, remember that they sell the trust. So if you have a trust, then you can manipulate it. Okay, and unfortunately we have to move, and we have the last question from the. So anyone? Okay.
Hi, so my name is TK, and I have 2 questions for you. With this thing going on...
Yeah, last 2 questions.
Do you consider this blockchain sort of equivalent to the 2000 boom of all the .com boom? Is it the same thing, or does it have the same momentum?
Blockchains definitely have a lot of parallels to the internet, and it's definitely like a new kind of technology that has a lot of similar properties. I mean, I wouldn't say it's the exact same thing, and there are a lot of things that are different. So like one of them is obviously that blockchains run on the internet. Yeah. So, and you can, you know.
Tulips, also it's another prototype. If you take a look for the history, then okay. Mm-hmm. The next question, please.
Next question is, what do you think in the next 5 years adoption will be? Because most problems with blockchain is that either there's government regulations or companies are just not 100% on board. So what do you think in the next 5 years the adoption will be?
I think adoption is definitely going to continue increasing, but it depends a lot, and first of all, on the technology and on just how much the technology can handle. It depends a lot on just what kinds of applications end up being built successfully on the platform. So, and I think adoption is going to increase, but there's a lot of possibilities in terms of how quickly it increases and in what areas it increases.